Hi, welcome to Analytics for All. This is lesson 11 of Module 2 of our Python for Data Science course. This lesson we'll be working on pivot tables with pandas. I'm actually kind of excited about this lesson for you. This will be the first lesson really we're going to be introducing, actually analyzing some data. I promise you in the next module, statistics and visualization, and obviously in the last module, machine learning, we're going to be doing a lot of analysis, statistical analysis, looking at data, visualizing it, building predictive models, and even building some unsupervised models to try to learn more about data. But this is the first time we're actually going to dive a little into data analysis here, kind of dip our toes into it. Everything up till now, I'm sorry, has been the stepping stones you need to learn the Python skills to be able to do some of this. If you've never worked with pivot tables in Excel, they're an excellent tool for data analysis. They allow you, for lack of a better word, to pivot data around and, aggregate it, look at it in new views, group it together. We're going to show some of that, and let's go ahead, let's pop over into the website and see what we got. All right. So this is our. All right. So, as with all my lessons, I have a full write-up on my website, analyticsforall.org. I'll put a link down in the description. And for this lesson in particular, if you scroll down, you're going to see I have a file, K-mean, you can download here, download the data set I'll be working with, K-means1. In case you're wondering, K-means is the name of an unsupervised machine learning method, and this data set was from a K-means job I was doing earlier. So it's actually a data set you'll be seeing later in the later lessons. But for now, you can just download it, and we'll pop over to our Jupyter Notebook and take a look here. Let's go ahead and zoom in for you. All right. Now, as I keep starting all these, you're probably tired of seeing this PWD, present working directory, but what this shows you is this is the directory we're currently pointed at. Before, I've been opening the files by using the full extended, directory name, C/B, the whole thing. And that's been the file name. Instead, let's go ahead and change our directory to make it easier to open our file up. And we can do that using the OS module down here. The OS module stands for operating system. So think disk operating system. Anything you can do within a command prompt, create directories, move files, delete directories, delete files, rename files, everything you can do there, you can do using this module. And what we're going to do now is we're going to use the OS module in the chdir method, which means stands for change directory, to change our directory to my downloads. So go there. Now look at the present working directory. Now we're pointed to my downloads. Okay. Now let's go ahead and import our file as we did before. We have import pandas as PD. Our DF will be PD read EXL, K-means, then Excel file. And let's look at the head of the data we've got. And there we go. So we have a head. We've got, remember the first row is always just your index. That's your row index that did not come from my file. We have ID tag, model, work order count, average labor cost, problem, average cost travel, travel cost, and department. What this is this is a list of repairs done by a traveling ultrasound repairman to different departments. Okay? This is where I came from. I used to fix medical equipment, so this is kind of some of my stuff still says that. But let's go ahead and let's see if we can do something to analyze this data a little better than just looking at just a sheet. We're going to create our first pivot table. We're going to use the method pivot underscore table, and we're going to insert our data frame. That's our data. And I'm going to say I want the index to be department, and I want the values to be the average labor, and I want to sum them up. So I want, for each department, I want you to tell me how much labor was done for each job there. Okay? And there we go. So for radiology, they got 97. Ultrasound got, look at that, they got 1,800 hours. So we can quickly go through and see anesthesia, where this person's like advanced cardiology, and you can just see where they hung out, where they spent most of their time here. All right? So that's a very simple thing we did. And we did a single aggregate of sum, AVG labor. We can also change our aggregates. Let me go ahead and get some more space down here so we can look. Now we're going to go ahead and we're going to take two. We're going to take department and model. So let's look at not only the department, let's look at the model of the ultrasound. Let's see which one, and we're going to go with a mean now instead of a sum. We're going to go with a mean function. So that mean, that's your average. Your geometric mean is your average if you haven't learned that in statistics yet. A mean is another term for average. That, so we go ahead and we hit that. And now we can look, and we can look at in the systems the different, like you'll see anesthesia's got a couple different ultrasounds here. X-ray special's got different ultrasounds. And you can see that these two ultrasounds down here require more on average labor time than this one does. And this is just a quick look. It's how we call pivoting through the data. And so instead of just having to count this out ourselves, we can just quickly make these pivots. So the next step we're going to do is we're going to go ahead and we're going to get, instead of more than one, category where if we did department and model, let's go ahead and get more than one of our values here. So we're going to look at average labor and labor costs. So we're going to look at our numerical values now. And we're going to do them both as a sum by department. And we're going to run that one. And there you're going to see you've got the average labor and the labor cost, average labor, labor cost, average labor, labor cost. These are all built in for different jobs. So this gives us a nice, look at all that. And finally, let's go ahead. Let's say we want, instead of both of these to be a sum, how about if I want one column to be a mean and one column to be like a sum? Well, that's where we can bring in our old friend NumPy. You remember that from the earlier lessons? So we're going to import NumPy as NP. And now we're going to do a little different. We're going to do a data frame group by department. And then our aggregate. So notice we're stacking methods here. You're going to see a lot. As you get deeper and deeper into this, you just start stacking methods. And our aggregate is going to be AVG labor. And I want it to return the mean, the NumPy mean, and labor cost, NumPy sum. There you go. So this is a couple different ways to make very simple pivot charts. We're going to get deeper into all this as we start to analyze the data. But what we were able to do, and this is kind of normally the first thing you do when you get a data set, is to kind of just say, hey, well, what's going on here? Let's see if I can look for outliers. Is it meaningful? Should anesthesia have that much more than everybody else? And, we go in there, count the machines, say, yeah, they should. Ultrasound should have that much more. So this is just an introduction using pivot tables with Python. If you enjoyed this lesson, I hope you hit the like and subscribe button. Go ahead, put a message down in the Sorry, I had a brain fart. Put a message down in the comments. If you do that, I've made some videos for people who put comments in there. If you have any questions how something works in Python, you're not sure, even if it's kind of out of scope of what I'm doing, and it doesn't have to be Python. It could be SQL, Tableau, almost anything data science related. I've probably seen it or touched it, can at least maybe help to try to explain it. Again, thanks a lot. My name is Ben Larson, and check out my website up here, over there, Analytics for All. I'll put the link down in the description again, and thank you so much.